My name is Faezah binti RAUF and I will be explaining the data flow from OUM student PC to online learning system server. First, we start off with application layer. This layer directly interacts with data from the student. Student requests an access to the network address of online learning system server. When the student is trying to access the system, the application layer sees network services provided to student application like web browser. The protocol used in this layer includes HTTP. In the presentation layer, the data then be translated from raw format into computer format. It will also be encrypted and compressed before it is transmitted to the online learning system server. The compression is made so that the data will be sent into the network in a smaller size. Next, in the session layer, it is responsible for the opening and closing communication between the student and the IT center. It ensures that the session stays open long enough for all the data to be transmitted and being exchanged before closing it to avoid any wasting resources. This layer also sets some checkpoints during the transfer of data, which the data transfer can be resumed from the last checkpoint when the session is interrupted somehow in the middle. The data transferred in the session layer then breaks into segments in the transport layer, and it is responsible for flow control and error control. It sends data at a rate that matches the connection speed of online learning system server and checking if data is received correctly or not. If not, it will request for the data again. Then, in network layer, it breaks the data segments into packets and finds the best path for the packets to be sent across a physical network. The network address in the packets is used to route the packets to its specified destination. The packets from network layer now breaks into frames, then be transmitted to the online learning system server after the connection between the student and the server's network are established. The MAC addresses of the students and the online learning system server devices are used to connect both devices and define permissions to transmit and receive data. Then, in the physical layer, it is responsible for transmitting data in the form of bit series of zeros and ones using the wireless connection between student network and the online learning system server network, while controlling the data rate. The data frames are then off from the student device and will be transmitted to the online learning system server. The student's access request has now arrived through the OUM network browser transmitted by the wireless connection. Then the bits of data is transmitted from the network to the online learning system server at the IT center. The online learning system server will identify whether it received an error-free data or not. If not, then the browser will keep requesting for the data to be sent again and again until it is considered safe from any errors. In the network layer, it will assemble the packets sent from the student's device on the online learning system server device. The student's access request arrived through the browser that has already been identified the location of the online learning system server from the IP address. The data packets will be combined into segments and data segments next be reassembled in this layer, turning it back into data that can be used by the session layer. It will also conduct error checking. If any missing of the data segment occurred, it will then retransmit the segment. Online learning system server will be receiving the data from the student's access request through the browser in the session layer. It will maintain, establish, and synchronize the interaction between the two communicating systems, then passing it to presentation layer for further action. Presentation layer, it will decrypt the data during the transmission and the data will be decompressed to get the original length of the data in its actual format so that the data will be received effectively. In the application layer, the access request sent from student device is being sent to the online learning system server located in the IT center. The access request has been granted.
Next session is subnetting calculation. In this session, we will ask you to show calculation on how to identify IP address that was assigned for online learning system server. Okay, what is IP address? It is normally expressed in dotted decimal format with 4 numbers separated by periods, and it includes a network segment and a host segment. We're using Class C address because its organization is small and network will have fewer than 256 hosts, so it is probably sufficient to use Class C address. And the address class is Class B. This is because its organization is large, so Class B address might be more appropriate to use. And finally, it is the IT center and faculty network address. This is the location and this is the network address. We will ask it to show that online learning system server finally assigned as first available address. We look at this table IP, this IP table. We look at the number 4. It is 192.118.128.0. This is the network address. And we put it here. Just copy it from the fourth available address here. Okay, now we continue to TCP/IP. What is TCP/IP actually? It is a short form for Transmission Control Protocol Internet Protocol. It is a suite of communication protocol used to interconnect network device on the internet. It is also used as a communication protocol in a private computer network and in internet or extranet. How to configure IP address on server? I will show you the step by step. Okay, first click settings and then click on network and internet and then click change adapter options and then right click on Wi-Fi, click properties and then click on internet protocol version 4 and then click use the following IP address. Below here also we use the following DNS server address and then we enter the IP address that we have been calculated at subnetting calculation for and then you click OK. Okay, so that is all the steps on how to configure IP address on server.
We use the subnet mask of 255.255.255.128, the IPv4 addresses from 192.168.243.1 to 192.168.243.30 are in the one subnet, and 192.168.243.33 to 192.168.243.62 are in another subnet. Therefore, direct IPv4 communication is not possible. We need a router or routing capable devices like a firewall to connect devices having IPv4 addresses belongs to those 8 different subnets.
As IP service invades our daily life and an unprecedented speed, the world would not be the same without the Internet Protocol. Therefore, the basic understanding of IP address, subnet mask, and network address is fundamental to successful TCP/IP configuration.
The thing that I discovered when doing this project is the benefit of subnetting. It can improve our network performance and speed. Subnetting enables you to ensure the information remain in the subnet network or broadcast domain, which allows other subnets to maximize their speeds and effectiveness.